the greater the chance of a ruptured placenta, placenta previa, a variety of problems, all right? Now think of the placenta as Velcro. I am fascinated by Velcro. You've got those two structures, you hook them together and they stick. That's what the placenta is. Baby's part comes from a structure called the chorion. Mom's part comes from a structure called the deciduum basalis, and they intertwine, they don't touch. Where they intertwine, they form a space, and that space is where the waste and the nutrients, oxygen and carbon dioxide, get diffused back and forth, all right? If that Velcro should rip apart, now you've reduced the amount of gas exchange, nutrient exchange that mom and baby have, and you increase the probability of baby dying, all right? When I started teaching here 15 years ago, there was a kid in my class whose wife was supposed to have a baby around Christmas. She slipped on a patch of ice right after Thanksgiving. She fell sitting down. She didn't think anything of it. She didn't feel the baby move all night long. She went to her doctor the next day, and guess what happened? The minute she hit that ground, that placenta ripped apart from the uterine wall. So for roughly 18, 20 hours, guess what that kid wasn't getting? Food, oxygen, removal of waste. Those wonderful doctors made her wait until after Christmas before they induced labor to have her deliver a dead baby. All right? So, be careful. You're going to see sperm model. I'm going to want you to know the sperm has the head where the nucleus is. This mid-piece, guess what we call the mid-piece? Mid-piece. This is where the mitochondria are. This is the flagellum, all right? The mitochondria produce ATP so the flagellum can whip around. On the very tip of the spear here, there's a portion called the acrosome. Now, you ladies are constantly trying to prevent our sperm from fertilizing your egg, even though your egg releases that chemical that attracts the sperm. Surrounding the egg is a protective barrier. In order for the sperm to be able to fertilize the egg, we have to use the enzymes in this acrosome to digest that protective barrier outside. Now, years ago I was taught, I guess it was high school, that I was a product of the fastest swimming sperm. Is that the case? No. We're all the products of the shiftiest sperm. What do I mean by that? Before that egg can be fertilized, I believe the number is anywhere from 8 to 12 sperm have to kill themselves by allowing the digestive enzymes to not only digest the protective covering of the egg, but also destroys the head of the sperm. Just enough to leave an opening for our sperm that we ended up coming from to go into that one spot where that protective barrier has been eaten away by the enzymes. The moment we fuse with that female egg, then there is an immediate calcification, if you will, surrounding that egg that prevents any other sperm from fertilizing that egg. And so we're not the fastest swimmer. I guess we were the generals that let all the peons kill themselves. All right? Yeah. Sometimes I look at my son and I say, and you were the product of that craftiest sperm. Boy, we're in trouble. All right, so you're going to see sperm model. You're probably going to see a picture of the mammary gland. All right? Now, the mammary gland has the nipple, has the areola, which is the tissue surrounding the nipple. You're going to have these bumps around the areola, which are called the Montgomery's glands. The Montgomery's glands release an oil that's got chemicals in there that kill bacteria. All right? So that when the kid breastfeeds, it's not going to get a mouthful of bacteria. Internally, this is diseased breast. You know what? That's all I'm going to ask about that, the mammary gland. You will definitely see this one right here. This shows you the ovary and the structures inside the ovary at various times of the female's reproductive cycle. Now, I'm going to disagree with the key here. I'm going to tell you that A is going to be what we call the primordial eggs. When you're born, women, conventional wisdom says that you have already undergone meiosis 1, and so you're born with a set amount of eggs that are in stasis. Anywhere from 450 to 2,500 eggs, they claim. although that conventional wisdom is being tested now because they've determined that this is all stem tissues, which allows you to undergo oogenesis continuously until menopause. So the primordial eggs become primary eggs, the primaries become secondaries, the secondaries become Graafian follicles or fascicular follicles. So this Graafian starts back up over here. Here's a Graafian follicle. This has got the mature egg in it. Ovulation has occurred. Now the sac, called the fecal sac, once ovulation occurs, degenerates into what's called the corpus luteum. And the function of the corpus luteum is to release progesterone. And you need that progesterone to maintain a thickened endometrial lining. In case fertilization occurs, you've got that tissue for implantation to occur. If fertilization doesn't occur, the corpus luteum becomes the corpus albicans, which is simply scar tissue. Now, the theory that's bouncing around why women go through menopause is that after so many years of having a menstrual cycle, you've accumulated so much of these scar tissues, the corpus albicans, corpora albicans, that you start having estrogen deficiencies, and that throws your cycle out of whack until ultimately you're postmenopausal and no more capable of having kids. All right? So I can't ask questions about those different things there. Take a look at that guy. As far as these models showing the embryology, I won't use these models, but I do expect you guys to know this right up here. I'm missing